Okay, so this video is meant to look at a particular example of induced EMF, and it's called motional EMF. And so it is when one end of a loop of wire is able to move when a force is exerted on it. So here's kind of the diagram of it. You have like usually a U-shaped wire, and then there is like a conducting bar, and this conducting bar can like move if there's a force on it, and it has a certain length L. And you could envision if it's got this length L and this is like a delta X as we move, you can kind of envision like this then would be an area, okay? So in this case, when we're looking at induced EMF, remember our equation for induced EMF is negative N times delta B A cosine of theta over T. And in this particular case, it's really only our area that is changing. Our magnetic field is not changing. Our orientation of the wire with respect to the magnetic field changing. The fact that we're moving this conductor, we're just either enclosing more field lines, so our area is getting bigger, or we are shrinking the amount of field lines we're covering. So we really, this equation becomes, remember if we kind of boil it down to just our area changing, this becomes negative NB cosine of theta times our change in area over our change in time. In terms of how this simplifies a little bit, it's just one loop, so this becomes 1. Our area vector and our magnetic field are parallel to each other, so this also becomes 1. And our equation becomes induced EMF is equal to negative B change in area over delta T. But we can describe our area as being our change in X times L over change in T, and delta X over T is just velocity. So we can represent this in terms of how fast is this like wire, this part of the loop moving. So the equation actually okay, so annoyed my video cut out. I didn't have enough storage on my iPad. So I was in the middle of saying that delta X over delta T is equal to velocity, and the equation then simplifies to be induced EMF is equal to negative BLV. Again, this is for a very particular scenario where you have this U-shaped conductor, this one part is moving, an external force is causing it to move at a given velocity, then the induced EMF that's created in that wire is equal to the magnetic field strength times the length of the wire that's moving, the part that's moving, times its velocity, okay? And so we will look at examples of how to do this particular type of motional EMF as well as like the grander equation of induced EMF.